Hello, ladies and gentlemen. Today we're going to talk about the early atomic model and how things have changed. So, we've already kind of talked a little bit about these people. You did a little research on them anyway. Today we're going to dive a little bit deeper. So, first person we talked about was Democritus, and we learned about this atomos, cannot be cut. So, that's where things are going to be starting. And we're going to pick up some people that we didn't get a chance to research. So, when you think of the atomic model, you probably think of this nice little ball with the neutrons and protons in the nucleus and electrons outside. And even this is a pretty simplified view of what we know about it. It's just all we show you here, usually in high school level. So, originally, though, it would have been thought of like a billiard ball. So, now we've learned so much more about the atom. So, what's been going on? We're going to look at these men throughout this chapter and talk about each one's discoveries that have pushed our model from that billiard ball to something much more complicated. So here we've got Democritus, who we said was ancient Greek philosopher. So he was a philosopher, not a scientist. He was not doing experiments, not testing things repeatably. He was just a thinker, just sort of coming up with theories about stuff. So his question was, what is mass made of? What is matter made of? And he thought that, like, if you had, let's say, a piece of wood and you cut it in half, and then you took that half piece and cut that in half, and you kept doing that, you would eventually come to the smallest piece of wood that could not be divided any further. And he would have called that an atomos of wood, right? Like an atom of wood, this indivisible piece of wood that couldn't be cut. And he would have said that, if you did that with, let's say, gold, that atom of gold would be different than that atom of wood, and it might be a different shape or a different size. And that's what makes gold different than wood, right? So that was his basic theory, and that there were these indivisible pieces called atoms that couldn't be cut, and they would be infinite and invisible and so tiny that you couldn't see them. Um, so that was his theory, but nobody really believed him. They kind of ignored him for 2,000 years. And what was a prevalent theory was Aristotle's theory. So Aristotle, also just a philosopher, not like a scientist doing experiments and testing things, but just a thinker. So he sort of suggested that everything was made of four different elements, and not periodic table elements, but these fundamental elements he called fire, air, water, and earth. So he would have taken that piece of wood from Democritus's example and said, okay, let's burn that wood. When you burn that wood, you see smoke coming off. There was air in that wood. You see fire coming off. There was fire in that wood. You see the ashes left over. There was earth in that wood. So that wood was some combination of air and fire and earth. And that made a lot more sense to people, even though, again, ultimately wrong. But for 2,000 years, that's pretty much what people believed. Now, you kind of have to remember that 2,000-year gap, things didn't really change for people very much between 400 BC and up to about, the 1800s. Things as far as human beings' daily life was pretty much the same. You were working to feed your family. That was probably the main thing you did. There were always, some people that were higher up in the social stratus, but for the most part, people live their lives never really traveling very far from where they were born, just doing the work that their families always did and just keeping going. So what's changing here in 16, 17, 1800s? You have the printing press being invented. You have people with free time, basically, to learn more about things. And so, especially aristocrats who have some extra time, don't have to go do things, and are just curious, are working with, they've got new glassware, they've got this printing press to print their ideas down and share them with others. So everybody's not just working, by themselves, and they're sharing things. So remember, that's a key piece to the scientific method is peer review, sharing things with others so other people can say, oh, well, that seems like a good idea. Let me try this and add this onto it. So they aren't just reinventing the wheel all the time. Now they can build on that knowledge. So that's a huge jump from here to today. Life for people has changed a lot. So if you took somebody from, I don't know, 1500 AD and put them back in 400 BC, they'd probably be fairly comfortable. They would be able to make their way through that world. But if you took somebody from our time and put them back in 1803, they would have a really hard time adjusting because our lives are so different now from what they would have been back then. Because mostly science and technology has brought us a long way. So each person who observes some new thing in science, it'll lead to some new piece of technology, which then leads us to discovering some new thing in science. So then we get microscopes, for example. Then we find out about, even smaller things that we can't see. And those lead us to new theories, and we just keep on snowballing that knowledge. So let's talk about a couple of those people, Lavoisier and Proust. So, excuse my pronunciation of any names. I am from Kentucky after all. So when Lavoisier talked about the law of conservation of matter, so you think about, we've mentioned this before, matter can't be created or destroyed. So Lavoisier was doing his experiments in his little laboratory with glassware and say burning something and containing all those gases and saying, it looks smaller, but if you keep the gases, the masses are all the same before and after. And his work is being shared around, and Proust also comes up with a law called the law of constant composition. So Proust is also breaking things apart like water in his experiments and, separating the gases that come from them. And he says, every time I break apart water, I would get 88.9% oxygen and 11.1% of its hydrogen. Every time. Water's always the same. So he called that the law of constant composition. That's sometimes also known as the law of definite proportions, since they're always the same proportion. So these two are sharing their work around, and it gets picked up by this guy, Dalton. Now, Dalton is just one of those people that can make those big leaps in science. So if you ever heard that fable about the elephant, where three blind guys are touching different parts of the elephant, and the guy at the trunk, he thinks it's a snake, and the guy is touching the leg, he's like, nah, it's a tree, and some guy's got the tail. I can't remember what he thought, but none of them can see the big picture. So Dalton's the guy that stands back and says, wait a minute, you're all touching an elephant, right? So he takes what Lavoisier is doing, and he takes what Proust is doing, and he says, okay, the reason that nothing is created or destroyed and that they're all coming is because they're these atoms are indivisible, right? Like Democritus said. And the reason you're getting these constant compositions, Proust, is because these atoms are coming together to form compounds. So he comes up with his atomic theory. And his atomic theory says that elements are composed of atoms. Atoms are indivisible and indestructible particles. So again, here you've got Democritus's term atoms and the indivisible, indestructible particle part. Okay, so nothing is created or destroyed for Lavoisier's constant law of conservation. And then it says atoms of the same element are exactly alike. Sounds a lot like Democritus. Now, we now know that this isn't actually right, but we'll talk about that later. Again, we're not saying he was right about everything. It was just the great place to start, one of those big leaps in science. And so he said atoms of different elements are different. So yeah, like Democritus would have said, gold is different than wood. Well, in this case, he was talking about atoms being the smallest piece of the periodic table elements. So oxygen. The smallest piece of oxygen would be an atom of oxygen, and that would be different from an atom of hydrogen. But those things are going to come together to form compounds, like Proust is saying with his law of constant composition, and that's what the atoms are joining to make these compounds in specific ways. As far as the atom Dalton was concerned, he would have had the billiard ball model, so it just looked like a round ball. But that those balls were somehow different from one another. And of course, he didn't really have any way to know what that was. So it's going to be the upcoming scientists that are going to get more technology and discover something new about the atom. We're still getting more technology and discovering new things about the atom. We still have particle accelerators now that are smashing atoms apart and trying to figure out what the little pieces look like so that we can get that full picture of what it's like inside the atom. So, his theory became the foundation for modern chemistry. Now, we are going to learn a lot more about this stuff in the upcoming chapters, but right now I'm going to take a little break and let you answer some questions about Proust, Lavoisier, and Dalton, and Democritus. So remember, Democritus was the ancient Greek philosopher, not testing anything, but coming up with that theory of matters made of atoms. Then you have Lavoisier, law of conservation of matter, nothing's created or destroyed, followed by Proust, the law of constant composition, so everything is always in the same proportions, definite proportions. And then Dalton sort of bringing it all together. Elements are made of atoms. Atoms come together to form compounds. Those atoms can't be created or destroyed. So, I'll stop there. Have a good day. Good luck on the paper.